All right. So a 50 kilogram box skids to a stop over a distance of 5 meters. What is the coefficient of friction acting on it? So let's just draw a picture of what's going on. So if it's skidding to a stop, first of all, we know that it has weight and we know that it has normal force. If it is skidding to a stop, so it's moving in this direction and it's going to come to a stop, the only force that's acting on it has to be friction, and it's acting in a negative direction. So the friction force is in a negative direction, slows it down. So the only force that's actually making it slow down, accelerate, change its velocity is friction. And it's a negative number. And acceleration will be a negative number. So in order to find that coefficient of friction, right, I'm going to need to know the friction force. But first, I've got to find MA. So here's a great example of where we don't forget what we know. This box has an initial speed of something, and it's going to come to a stop, and it's going to do it over 5 meters, and we need to know its acceleration. So let me give it, it doesn't tell me what its initial speed is, but let's say it's 10 meters per second. Okay, 10 meters per second. So I'm going to find my acceleration. Need a formula that has these values in it. No time. The only formula I have is VF equals VI squared plus 2AX. So VF is 0 and VI is 10. I'm going to have to square it. Plus 2 times A times 5 meters. So I'm going to subtract 10 squared from both sides. So that's going to be negative 100 meters squared all over second squared equals 2 times 5, 10 meters times A. So if I divide 100 by 10, I'm going to get negative 10 meters per second squared. Okay, so FF equals mu Fn. Well, Fn is equal to the weight. So Fn is equal to Fg. I've got 50 kilograms. So that's 50 kilograms times 9.8 meters per second squared, which is 490 newtons. So FF, I'm going to plug, is also equal to MA. So I'm going to plug these in. Mu Fn equals MA. And mu is going to be equal to MA divided by Fn. M is 50 kilograms times negative 10.0 meters per second squared. Divide, and remember there was a negative here, so I'm just going to distribute that out. Negative, because FF is negative. My MFN is 490. So if I take 50 times 10, which is 500, and I divide it by 490, so once again, 500 divided by 490, I'm getting 1.02. Now, the negatives go away, right? The negatives go away because friction is negative and acceleration is negative. All right, let's talk about the problem that's on your homework. A man pushes a 50 kilogram mower with a force of 100 newtons at 30 degrees. Assume the coefficient is 0.25. What's the frictional force and the acceleration of force? So first of all, friction It's just going to be mu Fn. So let's figure out what Fn is. So he's pushing down like this, which means that he's pushing with a Tx and a Ty. So when I draw this, I'm first going to draw the Tx in, and I'm going to draw the Ty in. It also has weight acting on it, so the normal force should be equal and opposite to both of those. And we have friction in the system. So in the y direction, all the forces add up to 0. So Fn has to be equal to Ty plus Fg. Well, Fg is going to be 50 times 9.8, which is 490. And Ty is just going to be T sine theta, which is 100 times sine of 30, which is 50 newtons. So Fn is going to be equal to 490 plus 50, or 540 newtons. So FF is simply going to be equal to 0.25 times 540 newtons, which is 135 newtons. Now it wants to know the acceleration. Well, in the x direction, right, all of the forces add up to make it accelerate. The only two forces in the x direction are Tx plus a negative friction. So Tx is going to be T cosine theta, which is 100 cosine of 30, which is 87 newtons. So this will be 87 newtons minus friction, which we found 135 newtons, equals the mass of 50 kilograms times A. And A is going to be 87 minus 135 divided by 50, or negative 0.96 meters per second squared. It's negative because it's coming to a stop. All right. Let's talk about a modified Atwood machine. So let's say that we have 20 kilograms here and 50 kilograms here. And we want to talk about how this is going to change our system. So how would it change the system? Well, when we talk about mass 1, it's going to have tension acting on it, and it's going to have friction acting on it. It's going to have its weight, and it's going to have its normal force. So if mu is 0.1, okay, then FF is going to be mu Fn, and Fn is just equal to Fg1, right? And Fg1, so that's going to be 0.1 times the mass of 20 kilograms times 9.8 meters per second squared. So the friction force is just going to be 20 times 9.8, 196 times 0.1, or 19.6 newtons. So if I write the formula in the x direction, right, all of the forces in the x direction are going to make this accelerate. It's accelerating to the right, so it's going to be T minus FF equals M1A, T minus 14.6 newtons equals 20 kilograms times A. And in the y direction, it's balanced, so that's why we know Fn equals Fg. So this would be the net force equation. Instead of just T equals 20 times A, it'll be 20 minus the friction. So then you would go through and solve your problems the way you do them all.